You've seen them everywhere, right? Large language models. They can be absolutely incredible, but they can also be, well, incredibly wrong. They can write you a poem, fix your code, plan your next trip, but their knowledge is fundamentally frozen in time. It's all based on the data they were trained on. So what happens when the world moves on and the facts change?
So here's the thing. This brings us to the LLM's biggest blind spot. Their knowledge is static. You see, they're basically generating stuff based only on what they've already learned, which means they have zero access to real-time information and can't just absorb new discoveries on the fly.
All right, let's make this real with a simple question, one that was actually used by a researcher at IBM. Which planet in our solar system has the most moons?
What do you think? Take a second. You probably have an answer ready to go.
So what happens if you ask a standard LLM this question? Well, it's not just going to give you an answer. It's going to give you one with this incredible, almost unnerving confidence. Jupiter. It might even rattle off an exact number of moons, sounding completely certain. And here's the kicker. That super confident answer? It's wrong. The correct answer, thanks to recent discoveries, is actually Saturn, which now has a whopping 146 confirmed moons. And this right here just perfectly nails the two huge challenges with LLMs. Their knowledge gets outdated fast, and they usually don't tell you where they got their info, leaving you totally in the dark.
Okay, so how do we fix this? I mean, how do we give these amazing models a library card to the real, constantly changing world? Well, the answer is this pretty brilliant framework called Retrieval-Augmented Generation, or for short, RAG. So what is RAG, really? At its heart, it's basically a system that connects a large language model to an outside, always-on knowledge base. That could be the internet, a company's private files, whatever. Think of it this way. It lets the model look stuff up before it even tries to answer you.
Okay, so how does this whole thing actually work under the hood? It's actually a surprisingly simple, three-step process that totally changes how the AI comes up with its answers.
So it all starts with you, right? You ask your question, which planet has the most moons? But here's where it gets different. Instead of just blurting out an answer, the RAG system hits pause. First, it goes and does a search, retrieving fresh, relevant documents from its knowledge base. Then, and only then, does it feed both your original question and this new info into the language model. The result? An answer that's actually grounded in real, verifiable facts.
And that right there is why RAG is such a game changer. It's all about making AI smarter, not just cramming more and more data into it. Instead of trying to build one single, impossibly huge brain, you're just giving that brain the tools to go find information on its own.
Now, to really get why RAG is so valuable, it helps to put it side by side with another technique you might have heard of called fine-tuning. See, fine-tuning is this massive process. You have to retrain the entire model on some new data. It's expensive, it's slow, it's a whole thing. RAG, it's way more flexible. You just update the external documents, not the model itself. This is perfect for keeping things fresh, and it lets companies hook up their own private data securely without ever having to expose it during training.
And this quote just nails it perfectly. You're not trying to perform brain surgery on the AI itself. You're just giving it a library card and telling it to go read. It's way more efficient, way more scalable, and just makes more sense for a world where information is always changing. All right, so let's just run through the big wins here. With RAG, you get access to fresh information. It cuts way down on those weird AI hallucinations, where the model just confidently makes stuff up. It lets companies use their private data safely, it provides sources for its answers, and maybe the most important thing of all, it gives the model the ability to say, you know what, I don't know, when the answer just isn't there.
But let's be real, RAG is not some magic bullet. While the idea itself is pretty straightforward, getting a really solid RAG system up and running in the real world, yeah, that comes with a whole new set of pretty tough engineering challenges.
And this quote from a developer forum really says it all. Going from a simple little demo, a proof of concept, to a system that can handle real-world traffic and data, well, that's a whole different ballgame.
So, what are engineers up against? Well, there are some pretty big hurdles. First off, you've got bad retrieval. That's when the system just grabs the wrong info entirely. Then there's this really fascinating problem called lost in the middle, where studies show that LLMs often ignore key facts buried in the middle of a long document. You add in issues with speed and just trying to figure out if it's even working well, and suddenly you've got a seriously complex puzzle on your hands.
And yeah, that whole evaluation thing, it's a massive challenge on its own.
Get this, some research actually shows you can get more consistent results just by tweaking how the model formats its answers. So getting past all this takes really careful engineering and totally new ways of measuring success, using new metrics like faithfulness, which is basically a score for how well the AI's answer actually sticks to the facts in the documents it found.
But look, even with all these challenges, RAG is a huge step forward in making AI systems that we can actually trust. It's going from this cool, niche idea to being a must-have piece of the puzzle for any serious AI application.
What RAG is really doing is transforming these models. It's taking them from these impressive but kind of unreliable idea generators and turning them into dynamic, fact-checking tools. And that is what lets us build AI tools for people like doctors, lawyers, and financial advisors. Jobs where being up-to-the-minute accurate isn't just a nice-to-have, it's everything.
So, all of this leaves us with a pretty big final thought. We are literally building systems that aren't stuck with what they were taught in school. They can now go out and actively learn stuff on demand. So as this tech gets better and better, giving AI a key to pretty much all of human knowledge, maybe the biggest question isn't what the AI knows, but what on earth we're going to choose to ask it.